This is the equation that we had on DESMOS, and I asked you all to show your work and to show it using elimination. I know a lot of you guys, or some of you guys, did these on IXL, but you may have used a graph or used a web app or something like that. And by the way, those are good to use, but if you don't show your work when we do a test, you won't get any credit. So I'm going to show you right now how to show your work and how to get the answer, of course, also. So let me make some notes while we're doing this. I want to remind you all that we're using elimination here. So as I go, I'm going to put, we can solve this type of system of equations using the elimination method. And let me make that small enough so we can have more room here. Just okay. Stretch it out a bit. Now the elimination method means that that we can get rid temporarily, anyways, get rid of one of the variables. And by that I mean one of the letters. The nice thing I like about this kind of problem is that you can either get rid of the x first or the y. I'm going to do it both ways. In fact, I'm going to have another recording, and I'll put a link to it on your assignment sheet. It'll be the same problem, but I'm going to do it by eliminating a different variable. Well, there's two variables here. The first time I'll eliminate the x, and the second time I'll do it with the y. You'll find that a lot of times one way might be easier than the other, and that's why I want to show you both ways. So right now, for instance, or for example, we can first eliminate the terms with x. Okay, and when we do that, we'll have a much simpler equation, right? So let me move this around and put that note up there. Now, if we want to eliminate the x, I want to focus for just a second on these two terms that have the x in them. Okay, and I'm going to use a word here that I want you to get familiar with, and I'm going to write this down. You don't have to when you do these problems, but it's a good idea. In fact, later I'll have an exercise where that's what I need you to do is just write down what I'm going to call the lowest common multiple. Okay. Now, a lot of people can do this in their head, but some people can't. Let me copy this note here. Okay, so if you cannot find a common multiple in your head, here's a way to find it. Okay. In this problem, we have we call these coefficients in this system. The coefficients for x are 4 and 5. And we need to find the lowest common multiple of 4 and 5. Okay? So this is simple arithmetic. The multiples, let's do the multiples of 4 first. The multiples, we're just going to count by 4 is all, of 4 are, the first one is 4, 4 times 1, 4 times 2, I'm not going to use commas, I'm going to use spaces. The next one would be 8, 4 times 3 is 12, 4 times 4 is 16. Just keep adding 4. If you add 4 more, you're going to get 20. 24. 28. I'm going to go a little bit further. 32, 36, 40, 44. Now you don't have to, I want to stress that you don't have to do this if you can do these in your head. And you'll see in a second, yeah, we could have just multiplied this too. It is easier to do that sometimes. 44, 48, 50, did I add right? 52, 56, and 60. Right now, the multiples of 5 are, well, the first one is 5. 5 times 1. 5 times 2 is 10. After that would come 15. After that would come 20, 25, and so forth. You just go to a few more here. 30, 35, 40, 45, 50, 55. I'm sorry, 55, and 60. A little space here, maybe. Okay. Now, when I say we want the lowest common multiple, by the way, I'm going to fix that note here. I'm usually going to use an abbreviation for lowest common multiple. If I can get my cursor to go where I want here. That abbreviation we'll often use is capital LCM. That just means lowest common multiple. So I want you to look at these multiples. They have some things, some numbers in common. The numbers that they have in common, let's start with green. They both have a 60. They both have a common multiple of 60. I'm going to zoom in so we can see that better. There we go. They both have a 60. They also both have a 40. And they also both have, I'm going to use a different color here, a 20. So we could use any of these multiples that are common, but we want to use the lowest, the smallest, the easiest one. And so for that reason, we want both of those, that 4 and that 5, to have a positive 20 and a negative 20. Okay, because 20 is our lowest common multiple. We want opposites. So I'm going to move this note out of the way, but we'll still be able to see it later. If I could get my buttons right here. Let's just move this off to the side. All right. All right, so what we'll want to do then is make sure that this 4 and this 5, instead, the numbers that are in front of the x's have a positive 20 and a negative 20. And here's what we'll do to do that. In order to get a positive 20 in front of the 4x, we need to multiply 4 times 5. That will give us positive 20. I know some people like to call this the claw. Again, we're going to multiply 5 times everything. The correct word is the distributive property. We're going to multiply 5 times everything in that black parentheses, everything that's black inside of the parentheses. We also need to get a negative 20. So on this second equation, we want to multiply by negative 4. Because negative 4, again, if we use a distributive property, let's use the proper word here. If we multiply all those terms, we'll get, I'm going to go ahead and do it now. So first on the top, let me do that. Let me do the top. 5 times 4x is 20x. 5 times 3y is 15y. And 5 times 8 is 40. And we'll do the same distributive property. You don't need to draw these lines, but I'm just showing you. First, I'm going to multiply. Let me make sure this is clear what I'm doing. First, I'm going to multiply negative 4 times 5x. That's going to give me negative 20x. Then I'm going to multiply negative 4 times 4y. That's going to give me negative 16y. And then I'm going to multiply negative 4 times 13, and that's going to give me negative 52. Negative 52. So I want to remind everybody, I said it earlier, that there is more than one way to do this. I'm only showing you one way. Now, I'll show you the other ways later. But now what we want to do is add all these equations. Or I should say add everything in both of these equations. Now, the reason I said what I said a minute ago is today I said I'm going to show you how to add these. There's another way to do it, and that's subtracting. I'm just not going to show you that today. Okay, so if I add everything, it doesn't really matter which ones we add first, but what I'm going to do is start on this side. If I add these are called the constants. If I add 40 and negative 52, I get negative 12. Okay, so that'll be negative 12. And let me get rid of that thing now. If I add these two, positive 15y and negative 16y, I get negative 1y. And here's the nice part about this. If I add these two, the part that makes our problem much easier, I get 0. And we don't even have to write the 0. We don't want to write the 0. In fact, we're just going to cross these off. Okay. So what we end up with now is a much simpler equation. Negative 1y is equal to negative 12. Need to move that more out of the way here. There we go. So we just need to divide both sides of this equation by negative 1. And the negative 1s will simplify, and so we'll have y is equal to negative, I'm sorry, is equal to 12. Negative divided by negative is positive. Y is equal to 12. Okay. And we were able to do that because we eliminated x. We had an equation right here that didn't have an x in it. Because we added negative 20x and positive 20x, we eliminated it. And we have a much easier equation. We're not done, by the way. We found y, and now we need to find x. I like this next part because you get a little bit of freedom here. You want to go back to the original two equations. Let me call them the yellow equation, and the other one let's call the green equation. You could pick either one of these. They will both work. I'll choose the first one. I'm going to write that, it's marked with yellow. I'm going to write that equation, the one that's marked with yellow, on my paper. And it's going to say 4x. But watch how I write the y. The way I'm going to write the y is in parentheses for the moment. And so we just said a second ago, we just said that that y, I'm going to change colors here. We just said a second ago that y is the same as 12, or it's equal to 12. That means whenever we see a y, we can replace it with 12. I like to say erase and replace. We're going to erase that red y and replace it with a 12. You don't have to use colors, of course, but I kind of like to. Put a 12 here. We again have an equation that's easier because there's only an x in this equation. Did a little bit of arithmetic here. 3 times 12 is 36, so we're going to have 4x plus 36 is equal to 8. We'll do some more simple arithmetic. Subtract 36 from both sides. I might want to make a little more room here. If we subtract 36, we're going to get, that needs to move up. We're going to get that 4x is equal to negative 24. There's 24, okay. And then we're going to divide both sides by 4. And so x will equal, is that, no, that's not right. I think I made a mistake here. 28, sorry, I did make a mistake, sorry. Negative 36 and 8 is negative 28. Sorry. Negative 28. And if I divide by 4, I will get x is equal to, let me do it in red. X is equal, hit my taskbar there, negative 7. So now we have X and we have Y. So you'll write your answer. And again, this is where I said, if you run out of room, if you show me the rest of the work or as much as you can, and then just put your answer. You got to put the X first though. -7 and +12 is the answer. Okay. -7, 12 is the answer. All right.